Good morning, everybody. I hope you're doing well today. What we're going to be going through today is our adding and subtracting fractions notes, which should hopefully be review for us because you guys did this last year, and I believe you got some work with it the year prior as well, but definitely last year. So just a little quick review. A mixed number can be rewritten as a whole number plus a fraction. So 3 1/2 really just means 3 plus a half. And now a spot that people often get tricked up on is when it's a negative one. So if it's a -7, that tells us that the fraction is also negative. The negative in front means that the entire mixed number is negative and not just the whole number in the front. So we're going to convert some mixed numbers to improper fractions, just a little bit of review. To do that, we are going to multiply the whole number by the denominator and add the numerator. So we have three groups of 2 over 2. So 3 times 2 is 6. 6 plus 1 is 7. So this would be 7 over 2. And again, the reason we multiply the whole number by the denominator is because it would be like if we have three groups of 2 over 2. And so that would be 2 over 2 3 times, which would be 6 over 2. And then add the extra one, that would be 7 over 2. Same thing for down here. We are going to multiply the whole number by the denominator and add it into the numerator. 7 times 8 is 56, plus the 5 is 61. So 61 over 8, the denominator is not changing, and it was negative prior, so it should still be negative now. But that's how we convert a mixed number to an improper fraction. Now let's go the opposite direction, improper to mixed number. And to do that, we're going to do long division. So the number on top always goes on the inside, number on bottom on the outside. And let's do some division. 2 cannot fit into 1 evenly, but 2 can fit into 19 9 total times. And 2 times 9 gets you 18. And 19 minus 18 is 1. And so we can now create our mixed number out of this. Now, normally when you divide decimals, you would, put a decimal point, bring down a 0, because we still have a remainder down here. When it comes to fractions, we're fine with the remainder. The remainder is just our numerator. So let's go ahead and create a mixed number. The number on top up here, how many times it goes in, is our whole number, because 2 fit into 19. Oh, that was interesting. 2 fit into 19 9 total times, and we had 1 out of 2 left over. Again, your denominator is not going to change. It's still going to be 2. And then your remainder goes on top. Go ahead and pause the video and try to do this next one. Alrighty, so if you pause the video and did this next one, you'd have 25 on the inside. You'd have 6 on the outside. 6 cannot evenly go into 2, but it can go into 25 4 times. Which 6 times 4 is 24. Subtract those, and we have a remainder of 1. And so again, we can create our mixed number. The whole number is going to be the 4. The denominator does not change. And whatever is left at the end of the problem is your numerator. And don't forget, it was negative, so it should still be negative. Alrighty, let's go and move down to adding fractions and subtracting fractions with like denominators. So just a reminder, you have to have like denominators or the same denominator to be able to add or subtract fractions. If you don't have it, you got to make it. And we'll look at problems like that here in a few minutes. But first, I always like to start off by circling the number and the sign in front of it, just so that I can see if they have the same signs or different signs. And I can see on this one, these have different signs. We've got a negative 7/12 and a positive 1/12. So we will need to subtract these. So 7/12 minus the 1/12. Now, really key thing to note here, I know the 7/12 is negative, but do not bring your negative down here, because now people would get confused and see, oh, we have the same signs now, so we should actually add these, which is not true. You already determined that they're different signs you need to subtract, so go ahead and just subtract your numbers like normal, and then figure out at the end if it should be a positive or negative answer. So if I subtract these, we're going to get 6/12. And keep the sign of the higher number, then you'll be exact. The higher number was 7. or I guess higher as in further from 0, higher absolute value. And so we will keep the negative with it. So this will be a negative 6/12, which we can reduce by dividing them both by 6, dividing the top and bottom by 6. And that would give us negative 1/2. You must reduce all of your answers or else you will be incorrect. So negative 6/12 would not be given full credit. Negative 1/2 is full credit. So let's go ahead and do one more together. Let's go down one problem actually. And then I'll have you guys do the other two on your own. So again, I like to circle the number and the sign in front of it. So let's go ahead and circle these up. So I can see that these both have the same signs. There is a minus and a negative, and we will always treat those as if they were the same. So let's go ahead and add these together then. We're going to add 8/9 and 7/9. Well, again, the denominator doesn't change. It's still going to be a 9. That's the groupings we have. We have 8 out of 9 groupings in one, 7 out of 9 groupings in the other. And so if we add these together, we will have 15 total out of with groups of 9. And they were both negative, so it should still be a negative answer. Keep the sign of the higher number. Now we've got an improper fraction here, and we will never leave our answer as an improper fraction. So I know 9 can go into 15 one time. And if I take one grouping of 9 out of 15, that means we will have 6 left over in the numerator. And then one last step, I can see the 6 and the 9 here, both can be simplified. They can both be divided by 3. So if we divide those both by 3, we would get negative 1 and 2/3. So go ahead and take a moment, pause the video, and try these next two. Again, circle the number and the sign in front of it, but don't forget there is something special we'll have to do down here on this one first. So go ahead and pause it and try these two problems. Alrighty, so hopefully you circled the number and the sign in front of it. And hopefully you would have noticed that these two up here have the same signs. And it's an addition problem, so we can use our adding rules of same signs add the two, different signs subtract. Keep the sign of the higher number, then you'll be exact. So same signs add the two. So we're just going to go ahead and do a 5/21 plus the 2/21, which would get us 7/21. And like we said, keep the sign of the higher number. The 5 is the higher number here, so we should keep its sign of a negative, so negative 7/21. And then we can also make sure that we reduce. So I can see that 7 and 21 can both be divided by 7. So this is going to be negative 1/3. Negative 1/3. Down here, remember I said we got something special to do here. Hopefully we notice we have minus and a negative. We need to bloop this or add the opposite. Do a little KAO. And now we can circle the number and the sign in front of it. And these have the same sign. So now we can add them. So 16/19 plus 3/19 is going to be 19/19. And if we have 19 out of 19, that means we have one whole. So we're done. The answer is just 1 here. There we go. That's a better one. Alrighty, so that is how we're going to add with like denominators. You just see if there are same signs or different signs, add or subtract them, and then keep the sign of the higher number and reduce if need be. 4 more questions here. I can add and subtract with unlike denominators. So now is when we are going to have to take an extra step because we have groupings of 7 here, groupings of 3 here, and those are not even. And so we will need to make these the same before we can actually do anything. So one thing I like to do is I like to list out the factors. So if we listed out the factors of 3, we'd have 3, and then 6, 9, 12, whoops, not 21, 12, 15, 18, and 21. These are the first 7 factors. And then we would also list out the factors of 7. So we'd have 7, we'd have 14, we'd have 21, and we could keep going, but hopefully we would notice that there's actually overlap with the 21s. This is the first number that both 3 and 7 can go into. This is called the lowest common denominator, or least common multiple. And so we're going to change these denominators to be 21s, because that is, again, the first number that both 7 and 3 can evenly fit into. Now, to make the 7 become a 21, we would multiply it by 3, because it's the third factor. 1, 2, 3. So we'd have to multiply this by 3. And whatever you do on the bottom, you always do to the top as well. You cannot just change the bottom and not change the top. So 2 times 3 is 6. So this is our new fraction. They are equivalent to each other. They just look a little different. And we have to multiply the 3 by 7 because it was the 7th factor. And we would also have to multiply the top by 7. So 1 times 7 is 7. And now from here, I can see, if we go ahead and circle the number and the sign in front of it, that these have different signs and we have to subtract them. So 7 21sts minus the 6 21sts is 1 21st. Keep the sign of the higher number. 7 is higher than 6, so we'll keep the positive. It will be a positive 1 21st, which means we are done right here. Let's go ahead and move on over to this next problem. So I can see, again, these do not have the same denominator, so we will have to make them the same. So you could list out the factors if you would like, or I know that 3 can go into 6, and 6 can clearly go into 6. And so we actually have a pretty easy denominator here. So the negative 1/6 isn't going to change. And the second fraction, the denominator, is going to become a 6. Now the first fraction, since it didn't change, we're already good there. The second fraction, we would have to multiply the 3 by 2 to make it become 6, which means we'd multiply the top by 2 as well, and that would become a 2. So again, a lot of people miss a common denominator that is one of the 2 denominators already. So like a lot of people wouldn't use the 6, they would use a 12 or an 18. You're allowed to use the 6. So if you can use one of the denominators as the common denominator, do it. It's going to make your life easier. So now we circle the number and the sign in front of it. We've got 2 negatives, which means they have the same sign. So we will add our 1/6 plus our 2/6. 1/6 plus 2/6 is going to be 3/6. And we want to keep the sign of the higher number. The 2 is higher than 1, and it was negative. And realistically, they were both negative anyways, so it should just be a negative answer regardless. And we can simplify this. 3 and 6 can both be divided by 3, which means the answer is going to be negative 1/2. Negative 1/2. Go ahead and take a moment, pause this video, and do these next 2. Remember, there's something special that's going to go on with this one over here. All right, so hopefully we paused it. Looking for a common denominator between 6 and 15, that is going to be 30. 30 is the lowest common denominator between the 2. So we're going to go ahead and add in the rest of this problem. So we would have to multiply 6 by 5 to make it become 30. So we'd have to also multiply the top by 5. Whatever you do to one, you always do to the other. So 5 times 5, 25. To make 15 become 30, we'd multiply it by 2. And so we got to multiply this numerator by 2 as well, which will get us 22. And then that is actually where I'm going to stop for this video because I'm running out of my time limit here. So I'm going to have you guys go ahead and start the next video after this one, and then that will finish up these notes.